Right. Hi, I'm Kaspars. I'm the lead developer at Gospelware, just a digital agency based in city centre of Newcastle. The topic of my talk is going to be Universally Isomorphic JavaScript. Before I start, I think I need to put this through. So I think it's one of the first announcement emails that I think Colin was the author of the text. And I was like, okay, well, it doesn't really mean much. And then suddenly I got taken absolute piss out from my colleagues because of this line. And then I discovered this stuff. I'm not sure who knows it. Some people might, some might not. But yeah, okay, so some of the topics on my talk might have been covered before slightly. I think it was a January or February talk by Ali Sheehan Dare. It was more React-centered. Mine's going to be a bit more general about universal or isomorphic JavaScript. So, first, a couple of questions. I'm guessing like most of you have used JavaScript before. Yeah, that'd be a silly question. So, who's used it in terms of like properly using frameworks like Angular, React, etc., like building large-scale single-page applications? Okay. Who's used any server-side JavaScript on Node? Okay, good. And who's heard the term isomorphic JavaScript, rendering, or universal JavaScript? And who actually knows what that means without just the rendering part? Okay, good. Right, so yeah, so the simple explanation would be it's isomorphic or universal JavaScript is, well, JavaScript applications are applications that can run both on the client and on the server, but it doesn't really stop just with the rendering capability. There's more to it, which I'll get into later. Obviously, most of the time, this will be in the context of single-page applications, because otherwise there'd kind of be no point, really. Yeah. So, just a bit of a background, I guess, on it all. So you know how like, you have your normal client-server architecture where the server will render all of your content, and on the front end you just have some like HTML templates, maybe with a jQuery to add some animations, etc. But you wouldn't really be rendering anything per se, maybe just making some AJAX requests. Then kind of something that's popular nowadays. Oh yeah, I should apologize because there will be a bit of backend components in this. I know it's running Northeast, but it's a 50-50 talk, so. So yeah, so basically client server with single page applications. That's kind of a very, very common approach nowadays. I think most people use that. So it's you'd have your backend server in any language you wish, even Node if you want. And then you'd have your front end, which would also contain like all of the application logic, the routing, rendering, and everything, and the data would be retrieved mostly by making AJAX requests to the API or the server or whatever. So the hybrid or the isomorphic approach, this is somewhat similar to the previous one. It's somewhat similar, only the difference would be that your actual application code can be run both on the server and the client. So essentially it means just less code, less duplication, which is great. And yeah, it's all handled within the same application. You can't really say whether it's rendered on the front end, the back end. It depends on how you use it, I suppose. So when did this kick off? So when did it kind of, the whole universal or isomorphic JavaScript thing started? So the first mention of it was in 2011, which is actually only just a couple of years after Node was released. I think it was like 2009, 10, sometime around then. So it was Charlie Robbins, and he was kind of looking. He said that JavaScript is essentially an isomorphic language because since Node.js, it can run both on the client side and the server side, so it kind of makes it isomorphic, I suppose. And he looked at most of the popular application architecture patterns like MVC, MVVM, etc., and see kind of are they good enough to be run on both platforms, the client and the server, or whether they'd need to make some sort of modifications to be able to run on both. Next mention was by Spike Brem from Airbnb, 2013. I guess everyone knows Airbnb. Do you know that they've been into running isomorphic applications basically since that year? So they're one of the first people who started it. He mostly looked at the single-page applications in general and talked about the drawbacks like SEO, performance to an extent, And then he went on about the whole hybrid approach, which is kind of like the first big popular article about it, I think. The next person was, well, it wasn't the next person to talk about it, but he's kind of like a key person in the whole universal versus isomorphic thing. That's Michael Jackson, not this guy, someone else. He kind of looked at the whole linguistic approach of which term defines it better, whether it's isomorphic or is it universal. So the differences. So these are the actual, I forgot the word now, basically the actual explanations of isomorphic and universal. So Michael Jackson's argument about it was that isomorphic doesn't really, in linguistical terms, doesn't really explain correctly what do those applications do. I think he kind of put it in basically, in other words, it's just two entities that are not the same, but they look the same. So it's like comparing, say, jQuery and Zepto, which is like a minified version of jQuery. Who doesn't know? It's basically they look the same, they use the same API, but they're completely different in terms of the code, how they're written. Same would be with like underscore or Lodash. That would be a good example. So they're similar in form, but they're written completely differently. And he says that universal, which the explanation is pretty good, it's applicable to all cases, is a better explanation for it. So like you could basically take this code base and you use it any way you want. It's universal essentially. I thought there's a guy called, I'm not sure if I'll pronounce it right, I think it's Gert Hengeveld. He came up with the idea that you should actually look at it slightly differently. You should look at it at functional isomorphism, which basically means seamlessly switching between server and client side in terms of rendering. And then you have the technical isomorphism, which essentially is the universal JavaScript part of it, which means that the same application logic, and the code can be reused on the client and the server. That's more like dealing with HTTP requests, even rendering partially, routing, module loading. So universal JavaScript essentially complements isomorphic rendering, if that makes sense. So they're kind of slightly different things. I can tell you more detail after the talk if you want to know. Yeah, so also the topic of my talk with Universally Isomorphic JavaScript, I thought was just a really bad dad joke, but it's not even funny whatsoever. So, okay, so why isomorphic JavaScript or universal? Why did it become a thing? So first of all, to enable search engine optimization for single-page apps. I mean, obviously, yes, nowadays Google will execute JavaScript and it will be able to parse the site anyway. I'm not really sure about Facebook, Twitter, and similar crawlers. I don't know if they do or not. But at that time, I don't think they did. That's a good 5-6 years ago. I don't think they had the capability then. Also, if the crawler has to execute JavaScript on your page, it kind of puts you lower in the page rank anyway because it takes more time to actually access the content that you want that you're serving. Second, performance. Unfortunately, I don't have a diagram to explain how it kind of works. But if you say you know how the single-page app would work, you hit the server would give you back static assets, JavaScript files, then the browser would have to parse them, make more API requests to fetch the content, then get the content, parse it, render it, display it. Whereas an isomorphic application would basically just hit the server, get back, get almost a static website back, and then fetch the JavaScript files and everything else, all the static assets, and then like progressively enhance it on top. So I think I'll get back to this topic slightly in terms of the times. I think it's one of the further slides. This is a good one. To make applications accessible in legacy browsers, say, well, with frameworks like Angular or React, I don't think they really support anything below IE9, but say if you wouldn't use those frameworks and would actually compose an application like that manually, you could make it work relatively nicely, even in IE 7, 8. I'm not even sure if it's relevant anyway, to be fair, but it's possible. Ooh, yeah, I've accidentally clicked that. Potentially to improve code maintainability means less code duplication, less code to write. To some extent, it increases the difficulty though, because you have to create abstractions for server and client side. And that was that from that. So yeah, so in terms of performance, I don't really have any benchmarks here. I didn't make any, as I'm lazy, I apologize. But from what I read, and I found a fair few, there's a couple of sources actually down there. One's from Ali's benchmarks and one's another article, and there's a few more. So you get, so basically, yeah, it's essentially less requests until your first meaningful paint. I was supposed to actually tell the whole request response thing now, so I'm sorry I did it before. But yeah, so basically, to actually get to your first meaningful paint, not the first paint, it makes less requests. So, by meaningful paint, I mean normally you could render a site, it could have some content, but not really anything readable in it. So it is the first paint, but it's not really meaningful. Whereas meaningful would mean if you can actually look at the site, you understand what's on it. Like it has content that you can read. Yeah, so you can reach up to 40% or even more improvement with this. Sounds like fake news, but it might not be. But yeah, it's on average, it's supposed to be about 25 to 40%, a couple of 100 to a fair few hundred milliseconds, depending on how bad your single page application is, I suppose. So, oh, that's an empty slide, sorry. So how do you get JavaScript to work on the server side? So the first problem you face is actually executing JavaScript on the server. So, as you know, obviously, we all know there's Node.js, which has a JavaScript runtime based on Google V8's engine. It's great, but can you do it in any other languages? Well, you can, but you probably don't want to, because you'd have to manually install a JavaScript runtime, then make it talk to your language of choice, say PHP or something, or .NET or Java or whatever. There are frameworks that already do it, but it just seems like unnecessary, really. Alternatively, you could also run a headless Node browser and just send requests from your PHP to that, and that'll return you back a rendered content, and you ship it back to the client. Again, extra requests, kind of pointless, really, so basically use Node. So, next thing is parsing HTML and DOM, and as we all know, the server-side implementations like Node does not have a notion of a DOM like the browsers do. They can't really parse HTML out of the box. So what you need to do, well, there's several different approaches. So what you could do is you could either use a Node-compatible DOM library, like JSDOM or Cheerio, which is essentially jQuery for the server. Alternatively, you could stick with like string-based HTML templating. Handlebars, Dust, and a fair few templating engines actually work both on the client and the server. Or you could use a UI component library. I'm pretty sure React and Angular kind of fall in that category because they have their own weird renderers. I'm not going to go into that. Right. Next is dealing with HTTP requests. So this is slightly less of a problem. It's just a tiny abstraction, I think. So in the browser, you would normally use the XML HTTP request under the hood of any other application. I mean, maybe the new, more modern ones would use the new Fetch API, but I doubt it, maybe in a year or so. However, on the server in Node, you have to make your library use the Node's HTTP or any other request engine, essentially. Routing, that's probably less of an issue. It's all string parsing under the hood anyway. So I think the only difference is that like in the server, when you actually hit a root, at least in terms of single page applications, they're all essentially get roots. You hit a root, you get a content, or you do something. There's no notion of the HTTP verbs. Whereas in Node, you have the whole request response object. So you would have to make your router work with both, depending on which environment you're in. Module loaders. We all know that Node runs on require. I don't think it supports ES6 imports. Does it? Does anyone know? I don't think it does. So module loaders, but we all know and love browserify, so not really much to mention with this one. Responsiveness, it's if you want to use any sort of media query replications in your app using the window object or something, you have to remember that the server side does not have a window object, so it's slightly harder to deal with it. Maybe you just need to abstract it away so that only ever occurs on the client side, or if you can think of an alternative implementation, go for it. And so basically, it's all abstractions and more abstractions. That's all isomorphic and Universally JavaScript is, more or less. So yeah, another thing good about it is it essentially is progressive enhancement. So on the first hit, you just get a static site. Say your JavaScript wouldn't work, you could still technically navigate around the site by clicking links, and they would still be rendered to the server all the time. I mean, obviously, you'd lose out on any sort of dynamic features like, you know, annoying pop-ups and whatnot. So yeah, and then if it all goes to plan, you render your first site, then that's when you fetch the set of your static assets, all the scripts, and then when you execute them, that's when the whole progressive enhancement magic happens. So essentially, most of the time, what they do is just hijack your links and make everything a lot more nicer. So like no page reloads, nicer animations, nicer page transitions, etc. I mean, yes, you can do it without the whole server-side rendering as well, but that's really not the point in this case. And yeah, maybe a slide demo. I'm not sure if you can actually see this. I'm going to try to run it. I think so. That's hold on. Can I pause it? Nope. I'll explain before. So that's the Airbnb's wishlist site. Airbnb basically runs everything on isomorphic JavaScript. So the first thing I'm going to do there is I'm going to hit the site with JavaScript disabled, and then if you actually monitor the network bar, you see whenever I change it to a different page, you'll see the whole page reload. And then when I enable JavaScript, you'll see a lot smoother transitions, and if you, again, monitor the network bar, you'll just see like requests coming in and coming in. There's really not much you can do. I mean, there's supposed to be maps there, but because there's no JavaScript, you can't. You can't really create a wish list or whatever requires any sort of dynamic action. So that does say disable JavaScript. And now if you keep an eye on the requests when the pages are changed, you'll see that they just keep coming in, and the transition was a lot quicker than it was before with your normal page load. And yeah, seems to work. Okay, so to quickly summarize pros and cons, the good, you get SEO. You'd get it anyway, but you get better SEO. And it's really not hard to actually set server-side rendering up, especially if you're using any of the more popular frameworks. Performance, maintainability, make legacy browsers suck less. Progressive enhancement, and I guess the only thing that kind of is bad, it can add complexity, which kind of, it's a bit of a trade-off with maintainability, really. But if you got the time, it's definitely worth it. So you'd say, why kind of use it? It sounds cool, but it's really not doing much. But a fair few companies do it. This is just a small list. Like Asana, they were actually one of the first ones. I don't think they do it now, but they used to. Airbnb, we know that, uses a render, which is basically Backbone. Coursera, online courses, Netflix. I mean, you wouldn't really want to watch Netflix with JavaScript off anyway, but like just to get that content preloaded quicker for you. It's nice. Drupal 8, I was surprised about that. Apparently it has built-in rendering, server-side rendering capabilities for Angular and React, I think, which is pretty cool. Mazda, they use that on a fair few of their sites. So, and just kind of quickly go through some tools and frameworks that you could use to make your life easier and kind of solve this problem with a few lines of code, really. So you have React DOM. We all know React. React DOM has a server component. I don't know exactly how it works. It's a bit of magic. I try to kind of go through the source code and realized, nope, it's pointless. Same goes with Angular Universal. With Angular 2, well, 4 or Angular, I don't know whichever one you prefer. Render, that's backbone with, I think it's with handlebars, yeah. Meteor, has anyone heard of Meteor? No, so it's basically like a full stack JavaScript application that has all of that stuff built in. It's stupid fast, it's unreal. Don't really know how it works, but it's great. Believe me. Next.js, this is Webpack, React, and something else. It's just like a little framework, so you could easily build these kinds of applications. So yeah, for routing, you still have React Router, Angular Router, Director, which is a third-party library. It allows you to use the router within both server and the client side, but you kind of have to write your own slight abstraction to be able to do it. Issue requests, Axios, isomorphic fetch, super agent as well. Solves it all for you out of the box. You don't need to do anything at all. Just let them run. Build tools, yeah, Universal Webpack is just a plugin for Webpack that makes your life easier in terms of bundling client and server code. And module loaders, Browserify, and Babel. That's more or less about theory. So I guess we have a break now, and then we'll kind of look. We'll look at a little application, an isomorphic application that kind of avoids using any sort of frameworks. Yeah, thanks. And that's thanks to Lewis. Yep, had to put it in. Right. So the second part is going to be just look at a little application I wrote, just as an example for this. Don't judge my code. I don't write just JavaScript on a daily basis. It's not perfect, but it'll do the job basically as an example. So I'll start with the libraries I used for this. So the server, Express, as per usual. Director for routing, handlebars for templating, Axios for HTTP, and JS DOM and handlebars for server-side rendering. And a bit about the application structure. So we'll have like a little API folder, which is just a little placeholder API, so we can actually test if it gets some data. Then have the public assets, not really important. And then in terms of the application code, you'll have the routes, which is basically all the route definitions, like the route pattern you're going to, and the handler function that handles the route, obviously. Route folder is going to be just the route handlers. Services, API, just the client. There's not much about this because Axios just does everything out of the box. I didn't really need to write any sort of an abstraction for this. Renderer and router, so those are like the main parts. So renderer is basically, it's not big, it's only really a few lines of code. It's just to show how actually easy is it to render stuff on the front end and the back end at the same time, really. And the router, that's kind of like the main bit because, as I said before, Director allows you to route on the server and the client, but it doesn't do it out of the box, so you need to kind of make it so. And yeah, the views, standard, and then the last files is just the client.js will just be the client bundle. Technically, if you bundle this file with the right template, you just throw that script into any, even in static, like if you just serve a static index.html file, this bundle should still work anyway. That's kind of like the point of isomorphic, is that it'll run either way. And the server.js is just a server-specific code. There's not going to be any specific notion of an application as such. It's just mainly about the router and the renderer. I do apologize if it doesn't make sense, but just ask questions straight ahead. You might not be the only one. Okay, so start with the client bundle, I guess. So all you'll do is just get the renderer, get router, get the routes, construct the renderer, construct the router. It takes the renderer as a dependency, and obviously the root definitions. This is the magical hijacking script. This is what I mentioned before. It's when the application actually starts, this script will just steal all the click listeners and make it use the router with this function here. Normally you do it on window online when you unload, when you just know all the content is there. So that's pretty simple with this. Server is a bit more complex because you actually need to create a node server as such, add some middlewares, etc. So as I said, we'll use Express as our server, use JSDOM as a DOM manipulation tool. We'll use, again, we'll need a set of these, renderer, router, and roots, because we need to construct them again. What I can show here, so if you see, the renderer is constructed with a document object, which is just your standard browser window document object, whereas in the server instance, you actually construct a DOM, like a fake DOM with JSDOM. Then you get the window from it, and then you get the document from it. That's just a bit of ES6 destructuring, I guess. That's what it's called. I'm not sure. Before that, you actually require the layout file, which contains all the base HTML, which is pretty simple. Where did it go? So, is that the one? Yeah. So the server, the JSDOM will take that HTML as basically as the main argument, and then construct a fake DOM for you that you use. Then get the document out of it, and then the setup is pretty much the same as it was before. You just use a different notion of a document in this case. You don't really need to worry about this. This is just so I can actually require HTML files, static middleware, so I can serve the bundle files from somewhere. That's a middleware for the router. It doesn't actually really do anything. It's just there for the sake of it. It's like if in case I hit an error, like it's not going to crash everything, it's just going to let it through. And then we'll just start a server from here. Is that more or less clear so far? Any questions? Okay, so we'll look at the root definition first, I guess. As I said, it's just a simple object, so we'll have the list root, and then we'll have a specific werewolf root. And then each one of those will require the appropriate root handler. Root handlers will be these. So, essentially just a function, like you can think of it as a controller. If you think of MVC, really, it's going to get some data, do something with it, and then render the content. So yeah, the basic root would. So there's a little is-server script, which basically this just is a little helper function for myself to know, like, if I'm in the server or the browser environment. Yeah, you can check the node process browser tab or window if you use not node or something else. So yeah, you get the API client. You get the view, which is just the handlebars template. I can mention beforehand, because we will see this later. So on the client, if you just use require to get a template, it'll just give you an actual HTML string. Whereas on Node, the way handlebars deals with it, it will actually give you a function that you can then execute with arguments that are essentially all the variables that you will have in the template after that. Does that make sense? So we'll look at the list handlebars template. It's pretty simple. So you'll just see where's it rendered. You'll have a list of items you just iterate over, and then each of those items will have an ID and a name, and that just creates a set of links. Pretty simple. Yeah, so Axios, the API client that uses Axios to get the data. When we get the data, we can just pass it to the view. This render function. I will explain where this thing is coming from later on. List item view, pretty much this. Yeah, it's literally the same, just slightly different parameters. So we'll show like a name and a picture, and that's about it. Nothing too fancy. Right, so the next step, yeah, I'll show you the API client. It's not the API client. It's just kind of maps the. Honestly, I can't remember why I did this. You can't just go and use Axios get. So let's assume it's Axios get everywhere. Ignore this. This is just some defaults and whatever. Okay. So we've seen the root config. We've seen how the controllers or the root handlers look. So now we'll look at where the actual part of abstracting server and the client comes in. I'm not really sure where to start. Is it the renderer or the router? Okay, let's start with the router because renderer comes in later. So takes renderer as a dependency. And this is the part where I need to decide which router do I use, because director has a router which is the front-end router. If we use that, we wanted to use HTML5 history, because otherwise the whole isomorphic thing is not going to work, because the backend is not going to like the hash bangs and everything. And we just initialize it. If we're on the server environment, we'll use the HTTP router. So that's relatively simple. We'll get back to the load routes function after that, and then for this router, we're just going to expose a few functions from the actual director router. Just to make more sense, I'll just kind of quickly just call it director, so you know that's actually the director router there. So we'll expose the on function, which is an abstraction for where was it? One sec. Oh yeah, this is going to be used somewhere later on. Okay, so yeah, that's the on function. So if you're in the server environment, it'll use the get as the method on director. If you're in the front end, it'll use on as the method for this. And then you just pass in the root and the handler to it. Set root, this is going to be, this was used in the client bundle here. So that just takes the href value and calls it on here, and that sets the root. Simple. Dispatch, not really important. This was actually exposed in the middleware, but you don't really need to expose it if you don't want to. It's actually pretty irrelevant here anyway. So the root handler, the actually loading in the roots and kind of parsing the handler methods and everything. So this roots, that's the object that we saw. I'll see if I can do a split screen on this, but it might be a bit tight. It kind of works, so you just see the roots object. So all it'll do is it'll iterate over them. I will just assign this to router because functions, and didn't use ES6 because I was lazy. Yeah, just to kind of like, we all know, you know why I'm doing this, right? Or do I need to explain? It's just so I don't lose this context when I actually want to call anything on the router within these functions, which are separate scope. Like, it's a completely different scope from the parent function. It's like isolate scope. So root handler, we get that. So we take this root and so basically we get either one of these functions in here. Handler context, we want to pass the renderer to the handler context, so we can do this essentially. So this is how we're going to pass that renderer function to the root itself. We can pass anything we want, really. We can just pass the render function directly, or it's completely up to you. As I said, this is not perfect. It's just to show kind of what can be done with it. And then this will return the handler root function. That's pretty simple. So like in most cases, all it'll do is take the root handler, which is this, which is the list or the list item controller, call it by applying this context, the root context to it. So using apply essentially changes the this context of this function to whatever you want, really. So yeah, we can access renderer from there, and it'll just pass the arguments through. I think the arguments basically being whatever is in here. List item is a better because it actually has an ID. Yeah, so ID is just mapped from, if you have a variable like this, as with most routers, you'll just access it with the same name here. And And then in case we are rendering on the server, then what we'll do is we'll add the response object to the renderer. I'll explain you when we'll actually look at the renderer, you understand why do you need the response object there. The response object is only ever available in the server context. You won't get it in the client. It's because this function, this root handler, is actually called within the context of director. And if you call director get, you'll get the request response something else. If you call director on, you'll just get the URL and just the parameters, and that's it. Okay, is that kind of clear? Any questions so far? Okay, and I'm not going to torture you much. It's just one more file, and then we're done with this. And then it's the renderer. Renderer is actually pretty simple. So I'll take the document as a parameter, as we looked at before. It'll either take the window document if it's a browser, or it'll take a fake JS DOM document if it's the server. Then you pass in a container ID if you want. So what we'll do is you get the document, and then it's just going to call the get element by ID to know which is the container where we're actually going to render the routes in. And I'll close this for now. And the other function is the render function, which actually does the rendering. So it'll take the view as the parameter. It can be a function if it's a server, because as I said, handlebars will return the require something .hbs, the handlebars template, as a function instead of as a string. And the data. This is what we got in the controller. So that's the data that we're passing through this object, essentially. So if let's start with the browser. So if we're hitting a browser, all it'll do is just change the inner HTML of the container to a compiled handlebars template. Very simple. If we're hitting the server, it'll do the same. It's a slightly different approach because this is essentially the same as this, only without the whole handlebars magic. It does the same thing. It will compile a template, basically. And then this was actually a lot nicer in a slightly older JS DOM version, because you could just take the actual content and serialize it there. Now I kind of have to create a copy of my document content as a new DOM, as a new fake DOM. And then I can call this response. As I said, that's why we'll need the response, because we actually need to give static content back to the client from the server. It doesn't just render. You actually need to return it for the browser to be visible, for it to be visible on the browser. So that, again, this is really irrelevant. They'll just send the serialized DOM, which is this, essentially just a string of HTML back to client, and that's that. That's actually it. Let's try to quickly run it. So I'll run my API, and then run, what was it called? Start. That's it. And we'll refresh this. Oh boy. What did I do? Alright, hold on. It happens every time, doesn't it? It worked perfectly before, I promise. I'll just reset all of this, and then we'll be back in business, hopefully. I have a shortcut for this. Oh, Jesus. I used the shortcut, and then I used the same thing again. Nope. You guys are not making this easier, you know. Right, so this should run. So we'll just rebuild it and rerun it. Come on. Hooray. So if you see like this, the page initially was rendered on the server. as this bit here says. That's the renderer essentially. And then we can look at, you know, a werewolf that's rendered by the client, and now every other request is going to be rendered on the client. Yeah, I didn't quite get this at first. Yeah. A werewolf, that's quite fancy. And if we do disable JavaScript, just to check whether it still routes to different paths. So as you see, like, it still works, but it's still the server. So it's just static content everywhere. And yeah, I think, how do I get out of the mirror mode? All right, yeah. Separate display. And yeah, that's it. Any questions?
Yeah, so how do you manage the detection between JavaScript and not JavaScript, and then switch between the two?
So I'll get back into the mirroring mode. So that's the little helper I saw that says is server. So this is the whole magic. So I use this in various places to detect whether I'm hitting the server end or the front end. That will define like how I route it or how I render it. So router has the capability. So imagine that router is like a combination of any front-end router you have, and it also has the capability to route the server, like any server-side router. So what I've had to do with it is basically kind of make an abstraction of a single function that, depending on the environment, will use either the server or the back-end side of it. That kind of, okay.
I assume there's some client-side code that knows to hit the server instead of running locally. Because obviously there's no JS locally if you disable JS.
The initial render will always be server-side because you are hitting the server physically. Well, not physically, but virtually. So it will always be that, and then after that, it's this method that both on the client side or the server side will know what to do with the rest. So like processes so Node.js, that's a global variable for Node.js, which is process, and it has an attribute called the browser, which says whether you're actually executing it within the browser. Or if you don't use that, you can just use the window object as a checker.
Yep.
Obviously, you have to use the right libraries to be able to achieve this, or it's going to be a bigger ball, I say. Yeah. Anything else?
Is this on GitHub?
Yes. Actually, if I go back to where is it? This? Yeah. So there's a little link at the bottom, or if you just go on my GitHub, it'll be like the Universal JS demo from Northeast.
I'll get the slides up on our SlideShare thing and tweet them out tomorrow. So.
Right. Well, if you have any more questions, you can see me at the pub. And thanks very much.